Okay, let's start our class. Am I audible? Okay. So, this is the last question of our module 3. After that, we will start another new chapter. So, in this chapter, we will get to know about various aspects of the road lighting. Now, road lighting is very important aspect of the road surface during the night driving. Okay, to increase the visibility. Now, if the visibility is not increased, in that case, there will be lesser visibility and there will be chances of accident and different hazardous conditions. Now, road lighting provides visual conditions for safe, quick, and comfortable movement of the road users. And roadway lighting on local street provides pedestrian visibility as well as driver visibility. So this road lighting is also very important aspects for cyclists or pedestrians for to increase the visibility during the night driving or walking. Now, lighting quality increase the comfort level and safety of the motorist as well as the pedestrians. And lighting can be expected to reduce night crashes by approximately 30%. So basically this 30%, what is written over here, this is the experimental result. Okay, by some practical experience, it is found that if you provide a good lighting condition, in that case it is very much effective in reducing the road crashes approximately by 30%. Now, the objective of the road lighting, as we discussed, is to supplement vehicle headlights, extending the visibility range beyond their limits both laterally and longitudinally. So, during the night driving, you have the headlight, but this road lighting helps to increase the range of the visibility ahead of you in addition to the headlight. Now, to improve the visibility of roadway features and objects on or near the roadway, to delineate the roadway ahead and improve the visibility of the surrounding. So, improving the visibility of the surrounding is very much necessary for a driver to know the possible hazardous conditions which is coming or which is coming around him. Okay, now to reduce the apprehension of those using the roadway. So suppose some users are or some pedestrians are using the roadway, okay, for walking or for some other purposes. So in such cases, these night drivers, with the help of these lighting conditions, road lighting conditions, it enable them to increase the visibility of the passengers or any objects surrounding him, which will reduce the chances of accident or any other mishaps. Now this visibility requirement. So first one is vision. Now the eyes are the primary source of informations, because as the light decreases, vision and the detection of informations are severely impaired or non-existent. So if there is light source, then only you can see, otherwise you cannot see. Now as the light increases, vision and the detection of informations are improved. So for this reason, during the daytime there is no chances of lesser visibility, because of the sunlight you can see all the object near to the road surface and on the road surface. So during the night time, if the visibility is increased with the help of road lighting, in that case it will enhance your vision. Then contrast. contrast is the difference in brightness between the object and the background. Suppose some object is there and that object is over the road surface. So contrast is the difference in the brightness between the object and the background. Now, the ability to discern objects increase as the contrast level between the two increases. So, generally, to increase the contrast, sometimes some reflecting objects are used behind the vehicles or any stationary objects which is situated over the road surface. So, whenever a headlamp light from the headlamp will directed on that object, then the reflective portions of that object will reflect the light and it will increase the visibility, or it will inform the driver that something is over there. So drivers normally see objects in silhouette, a dark area against a bright background. So silhouette means a dark area against a bright background. So basically it happens when the brightness of the object is less than that of the background. Now that is when the object appears darker than the road surface. So suppose some object is there which brightness is lesser than the road surface. In that case, that object will appear to be darker than the road surface. It is called silhouette. Now this bright background can cause a glare resulting in a reduction in the contrast level, thereby partially or totally obscuring the details to be seen. So therefore, in such cases, we have to keep in mind that we need to increase the brightness of the surrounding area so that no silhouette can be formed. Now, if the brightness of the pavement is uniformly increased, hence it is obvious that night visibility on cement concrete and other light colored pavements are better than on blacktop surfaces. Basically, cement concrete pavement, the color of the cement concrete pavement would be deep gray or a light gray color, and it is better for the night visibility than from the blacktop surface of the normal bituminous road. Now, a light colored rough textured pavement surface that can reflect light back is considered most desirable. Why rough textured? If it is smooth textured, in that case there will be chances of glare, so it will reduce your visibility, or it will hinder the vision of the drivers as well as other users of the road. Surface that becomes mirror-like or shiny, as we have discussed, when wet, such as smoothened blacktop road surface, should be avoided, as practically no light reflects back from them. So if there is a blacktop surface and if there is a rainy season, in that case, if the rain water sustained over the road surface, in that case it will create some nuisance for the driver as well as the users of the road surface. Now another thing is there, that is reverse silhouette. So when the brightness of an object is more than that of the immediate background, then it is called reverse silhouette. Now the objects adjacent to the roadway, projections above the pavement surface such as island or vehicles, may be seen by the process of reverse silhouette. So this is a process by which you increase the brightness of an object in such a way so that it can be visible from a far distance. Suppose one traffic island is there, so you will make the color scheme of the traffic island in such a way, or if you or you enable lighting conditions in the traffic island in such a way so that it can be visible from a far distance. So this mechanism is called reverse silhouette. Now when the pavement surface is very dark like blacktop surface, the object which are relatively brighter in color are seen by the process. So whenever there is a blacktop surface, to enable this reverse silhouette, what you have to do, you can paint the edges of the road with a white color paint or yellow paint, or you can put some light reflecting objects near the edges of the road so that the drivers may have an idea about the road boundaries. Now there are different factors which influence the night visibility. First one is amount and distribution of light flux from the lamps, that is light distributed from the lamp, that amount and how they are distributed. Then size of the object, brightness of the objects, brightness of the background, reflecting characteristics of the pavement surface, glare on the eyes of the driver, and time available to see an object. So these are the different factors which affect the night visibility. Now there are different light sources which are used in the road surface for the illumination purpose, and they are basically three types: LED, then filament lamp, and discharge lamp. Now in the filament lamp, this is incandescent, LED is only LED, and in the discharge lamp there are different types like fluorescent, mercury vapor, metal halide, high pressure sodium, low pressure sodium. Now basically maximum of the road lightings are LED, or they are converted to LED. So these are the luminance, means how they are emitting light. Okay, and these are the life of each and every lighting sources. Now LED, LED means light emitting diode. So an LED roadway light is an integrated light that uses light emitting diodes as its light source. So basically light emitting diodes are the light sources of the LED light. Now these are considered integrated because the luminary and fixer are not separate parts. They are as a whole a total parts. Now most LED roadway lights have a lens on the LED panel which is designed to cast its light in a rectangular pattern. So your pattern for the LED light is rectangular pattern. So some lights are there whose pattern is circular pattern for the illumination, but for the LED the pattern for the illumination is rectangular pattern, and it's aiming the majority of the light to the street side. That is also very important, and because of this feature only these LED lights and are very much used. Now the primary appeal of the LED roadway lighting is energy efficiency compared to conventional roadway lighting. Okay, so these LED lights are very much energy efficient, and LED fixtures uses considerable less electricity than the traditional light fixture. In addition, an LED fixture will have a longer life. So as you can see from the table, these LED lights have a longer life than from the other type of sources. Then next is incandescent lamp. So this incandescent lamp has a filament. Filament, that is an electrical resistance wire enclosed in a glass in a gas filled bulb. So basically, there are the conventional lights which you may have seen in the roadside. Basically, their shape is big in nature. Then from the LED lights, and current passing through the filament heating the filament to incandescence produces light. So the incandescence, whenever current passes through the incandescence, then it will produce, and by this heat, so this incandescent lamp illuminate the light. The gases are inert, usually nitrogen or krypton. This type of gases are used, which reduce evaporation of the filament and act as a thermal barrier. Why thermal barrier? So that the heat produced by the incandescence cannot go out of the light surface. Then another type is discharge lamp. Now the discharge lamp produces light by exciting gases or metal vapors in a lamp or tube. So some gas would be there. Okay, this gas will be evaporated from the discharge lamp, and by this discharge lamp will act. Now electrical potential is applied to the electrodes, and gas is ionized and current flows between the electrodes. So these lamps have a negative resistance. So these are the some primary principles of the discharge lamp. So basically you just have to know about the different types of the lamps and why LEDs are important. So basically that portion LED that is important for you, and what are the different design life of the different types of the light. So basically that is important for you, and these are some working principle. So you for the understanding purpose you can have a look about all these things, but that is not important for your exam purpose. Okay, then coming to the fluorescent lamp. So these fluorescent lamps produces light by fluorescent coating on the inside of the tube, which is activated by an ultraviolet energy generated by an arc. So these are different types of lamps, and they are the working principles of the light. So I'm not going to details about all these things. You just go through it. Now, this is important. The factors responsible for the lighting scheme for the roads are luminance level, luminance uniformity, degree of glare limitations, lamp spectra, and effectiveness of visual guidance. So let us discuss about all these things. So first one is luminance level. So as the luminance of the road influences contrast sensitivity of the driver's eyes and the contrast of the obstacles relative to the background. So luminance of the road means how much light is reflecting from the road surface. It influences contrast sensitivity. Means sensitivity means the difference between the brightness of the road surface and the objects and contrast of the obstacles relative to the background. Now hence affects performance of the road users. Now, surrounding brightness affect the adaptation of the human eye. So, if the brightness is more, human eye can see more prominently. Otherwise, our visibility would be reduced. Now, brighter surroundings, lower contrast sensitivity, thereby requiring higher luminance of the road surface. Now, roads with dark surrounds are to be lit by including surroundings. So, if the road surface is darker, in that case, if you provide the road lighting, in that case, it is used necessary so that the road surface as well as the surroundings is also visible. Otherwise, the drivers cannot perceive objects in the surrounding. Now, it is recommended that 5 meters away from the road on either side should be lit illuminance level at least 50% on the road. So it is recommended that 5 meters away from the road on either side. So if you provide road lighting in that for a blacktop road, in that case you have to provide lighting at least 5 meters away from the road is so that road surface as well as the surrounding of the road can also be visible. Okay, otherwise it will be problematic for the drivers because of the black uniform surfaces. The driver cannot visualize the surroundings and they cannot perceive the surrounding around the road surface. Then luminance uniformity. So adequate uniformity is necessary for visual performance. Uniformity means suppose you are providing the lighting, okay, or light post. So this light post should be distance similar from one another. Suppose you for the first two light posts there is a intermediate distance of 5 meter or 10 meter. So the next light post would be similar distance from the second one. So in this way you can maintain a luminance uniformity. Okay, so adequate uniformity is necessary for visual performance and visual comfort of the users. From visual performance viewpoint, uniformity ratio is defined by luminance, that is L minimum divided by L average. So what is the minimum value divided by what is the average value? So U0, that is the luminance uniformity, should not be below 0.4. Okay, so as it is 1, if it is 1, in that case it means that your road is 100% luminance uniform. Okay, so from visual comfort viewpoint, an uniformity ratio is defined as L minimum divided maximum. Minimum, that is luminance minimum divided luminance maximum value, measured along the line passing through the observer positions in the middle of the traffic facing the traffic flow, termed longitudinal uniformity ratio. So if there is a road surface, in that case okay, if it is divided, so first thing is you have to provide the lighting at a 5 meter distance so that this surrounding is visible, and second one is you have to put the lighting in such a way so that there is a uniform luminance or uniform illumination of the light from the light surface, so that the all this road surface the visibility of the road surface is uniform. So there is some number that is from visual performance viewpoint, uniformity ratio is L minimum, that is your luminance minimum. Suppose at this point your luminance point is found to be minimum and at this point it is found to be maximum, and you need to find out the luminance levels at various points, and after that you need to find out what is the average value. So from the performance viewpoint view, your uniformity ratio would be L minimum divided by L average, and from the visual comfort view your uniformity ratio is defined by L minimum divided by L maximum. So next is glare limitation. Now, psychological or disability glare affect visual performance. Psychological or discomfort glare affect visual comfort. glare is to be avoided at all cost. You know what is glare? Suppose you are driving your vehicle and in the opposite lanes, suppose one another vehicle is coming. So if the headlight of that opposing vehicle is facing your or directing to your face or eyes, in that case for a friction of uh, time you are not able to see anything. That phenomenon is called actually glare. So you have to limit the glare in the road surface. So how you can limit the glare? First thing is using the dipper. Another thing is, suppose one divider is there. So in the divider, you install some vegetation, okay, some trees, or you just increase the height of the that traffic island or median, so that the light of the vehicle coming from the opposite direction cannot go in the adjoining opposite lane. Okay, so in this way you can limit the glare of the road surface. So lamp spectra. So basically lamp spectra composition determines color appearance of the lamp. So what color of the lamp is. So suppose for the LED light, the illuminated light is white color, and for the incandescence, that is a bright red color. So this is lamp spectra. Then visual guidance guides the road users and hence must for user to get a recognizable picture of the course immediately. So that visual guidance is also very much required for the road users. So for the visual guidance, sometimes what happens, you have to paint the road surface with some white marking or yellow marking or some marking with reflecting property, so that it can use as a guidance for the drivers. Some basic requirements for using lamps. So these are the some basic requirements. It is economical to use the largest lamp size in a luminary, which will provide sufficient uniformity of pavement by brightness, but this also depends on the spacing of the lamps. So based on the spacing you can increase or decrease the sizes of the lamps. The various types of lamps in use for highway lighting are filament fluorescent. You know about this. So filament lamps are not at all preferred these days, because though the initial cost of the filament lamp is lowest of all these, the energy efficiency is the lowest. Therefore, in the long run, it will cost more. So sodium vapor lamps are preferred at large intersection for their increased visibility. So there are different road categories, okay, and type of the roads, and based on this road, see A B C D E, there are different type of lights and luminance level, so which is used for the road surface. That is not important for you, just you can have a look about this, so that in case you want to design some road lighting condition, you can design based on these parameters. Now, next point is light arrangement. So, depending on the road category, there are various arrangement for the two traffic roads. There are four types. First one is single sided. Single sided means, suppose this is a road, you are providing the lighting only in one side. Then staggered, located on either side of the road in a staggered or zigzag. way. So how this is look? This is look like this. Suppose you are providing one light over there, then another direction, then in this direction, then in this direction. So that is staggered. Then next is opposite. So in the opposite, it would be like that. So one over there, one here, one there, one there. Okay, this is opposite. Then spawn wire luminaries suspended along the axis of the road, only normally for narrow roads, suspended from cables strung between the buildings. So how it looks like? Suppose one narrow road is there, and suppose one post or some buildings are adjacent to this. Okay, so in the building, some wire would be suspended and a road light would be suspended from a wire, okay, which will be hang over the road surface. This is called span wire. Okay, so these are the different types: single side, staggered, opposite, span wire. Now, sometimes high-speed ways and lanes lamps may be located on the separators and termed central twin bracket arrangement. This is central twin bracket arrangement, and this is central twin bracket and opposite. Okay, these are the combinations of the lighting provided in the road surface where divider is there. Now, road junction, special care is taken at road junction as shown in figure. So, care is taken such that junction is clearly visible from a distance, should prevent traffic congestion, higher luminance at junction, using different colors at the junction, different arrangement to be for main roads and secondary roads. So these are the different arrangement of the road lightings in the intersection area. So this is for the intersection area where no island is there, and this is for the intersection where traffic island is provided. Now see in the second picture, as this is your major road and this is your minor road, so therefore there is differences in lighting condition in both the roads. Then curves, special care is taken on curves. Okay, in the curves there is some obstacles and visibility, so therefore you have to take special cares in the horizontal curves. So on radius larger than 300 meter, the curve can be treated as a straight road. Smaller radius curves, in the smaller radius curves, lamps are located outside of the curve, and smaller the radius, closer is the spacing, and usually the spacing is 0.5 to 0.25 times that for the straight road. So if in the straight road you are providing the light at a distance of 10 meter, so in the curved road that would be like 5 meter distance.